Okay, in this formula, P means principal, R means rate, N is the number of years. We started this problem, and we did the simple interest formula here, and then we're going to compare that to the compound interest formula here. All right, so we plugged in everything, 5,000, 5%, and 10. When you plug that into your calculator, this is what you get. You get $8,144.47. So you can see that with compound interest, he makes almost, what, $644 approximately, more than just simple interest. Right? So are there any questions on the difference between simple interest and compound interest?
No.
Wonderful. Now, as I mentioned in that, as the guy mentioned in that video, you don't have to compound once per year. You can compound every month, or every day, or every week, or every second, or quarterly, or semi-annually, or whatever. All right. So to take that into account, we have this formula, which hopefully looks kind of familiar to what the guy was writing in the video. But the only thing I want to add here is that, so we have K is the number of times it's compounded per year, and T is the time in years.
Can you write your T's like that? Like A's. Yeah.
No, well, for a variable I do a cursive T because otherwise the T's look like plus signs. So.
And if you just do like the normal lowercase t, like a little like swoop at the bottom, that looks good.
It does, but I don't write. I've never written my. I don't write my T's like that. So.
I don't like. I just do. I just like, and I just know.
Yeah, you guys do whatever you want. I'm not saying how you have to write your T's. I'm just saying that, like, early on in my career, like, this is my first rodeo, okay? Like, I would write T's and people would be like, is that a plus or a T? So I fixed it. Okay, here we are.
Most people want to write their T's with their T.
And then after, like, one day, everyone knows that that's a T and not an A. It's like, trust me, guys, I know what I'm doing here. Okay. Suppose Roberto invests $500 at 9% annual interest compounded monthly. Okay, that's 12 times per year. Find the value of that investment after 5 years. Okay, so I'm just going to make a list of everything that I know. Not literally everything that I know, but specifically about this problem. We don't have time for that. All right, so P equals 500. That's the principal. That's the amount invested initially. The rate, that is 9%, but we're going to put that in as a decimal, right? So 0.09. T is the time in years, that's 5. And K is the number of times it's compounded per year. So that's going to be 12, because it's compounded monthly. So if you plug this into your formula, over there on the left, the compound interest formula, you get this. 500 times 1 plus 0.09 divided by 12. All of that raised to the 12 times 5. Plug all that into your calculator, hit enter. If you typed it in correctly, you should get this. 782.84. That's how much money you'd have after 5 years. So you just put your money in the account and wait, and it'll turn into 782.84.
And that's,
if you can get 9% interest.
Including the 500.
Yes. Yes. So you made $282. Yeah.
Can we just skip the next? Or is it like the same?
Nope. They're not quite the same.
We don't have any notes for the text.
There's that too. Yeah. Okay, number 3. Judy invested $500 at 9% annual interest, compounded monthly. Same idea, right? Same setup. But now in this one, we want to know how many or how long will it take her to invest her investment to get to $3,000. So after 5 years, she'd turned her investment into $782.84. How long would it take her to get to $3,000? In other words, to what? Times her money by 6, looks like. So that $3,000 there, that's A. That's the final amount. So in your formula here, A is the final amount of your investment. And so you want to know, okay, when is 3,000 equal to 500 times 1 plus 0.09 over 12 raised to the 12 times 5. I'm sorry, 12 times t. Thank you. Yes. We're trying to find time. So you can probably do this algebraically. I think with what we learned the last couple of days, you could probably solve this algebraically, but the easiest way to solve it is probably to graph the left and graph the right and just see where those lines cross. And so what you find is that it's going to be after 20 years. Or around 20 years, or it's approximately 20.
You find out by could you graph and then
So
find
t
the
equals
intersection?
Graph and find the intersection.
was t equals 20.
Yep.
Did you get the right t equals 20?
Sure. T is approximately 20. Well, I mean, I don't know. It's asking you how long will it take, so
T equals 20 years.
sure. Okay. Questions on that one? All right. How about this? Kennedy invested $1,500 at 6% annual interest, compounded monthly. Okay, so we'll just plug in all that stuff. How long will it take her investment to double? Okay, well, we can at least get part of this equation. We know that she invests $1,500. 1 plus, the interest rate is 6%, so 0.06 divided by 12. Raised to the, it's compounded monthly, so it's going to be 12 times t. We want to know how long it's going to take to get to, how much? 3,000, right? Yeah, if she's investing 1,500, then she wants to see how long it's going to take to get to 3,000. Right. If you have $100, you want to know how long it takes to double. You want to know how long is it going to take to. Yeah, the amount invested, the principal. So again, plug this into the calculator, graph the left, graph the right, or you could, again, you could do it algebraically, but you get about 11.6 years. Questions? All right, what happens if we don't compound monthly or weekly or daily or by the minute? What if we do it continuously? All right, so if we compound continuously, the formula goes from this to this, where that part in the parentheses just becomes the number e. Okay, so in this, there's no new variables here. E is just that constant, 2.718, whatever. Okay, so let's use that formula here. All right. So suppose Letitia invests 100% at 8% annual interest compounded continuously. Okay. How much is her investment worth after 1, 2, 3, 4, and 5 years? All right. Well, all you're doing is taking that formula. Sometimes it's called the PERT formula, P-E-R-T, the PERT formula. All you're doing is taking that formula and you're going to plug in 100 times E to the RT, so that's 0.08 T. And then you're going to plug in T is 1, T is 2, T is 3, T is 4, T is 5. In your calculator, you have an E raised to the button. You've probably seen it. It's right here, this above the ln, e to the x or e to the whatever. Okay, so you can just take your calculator and you can do 100 times e raised to the 0.08 times 1. You get 108.33. Then you can do it again. Second entry, change the 1 to a 2. and just keep going. Or if you want to see the fastest way, you hit y equals, plug in 100 times e to the 0.08x, and just go to your table. There's t equals 1, 2, 3, 4, 5. So after 1 year, it's at 108.33. After 2 years, it's at 117.35. After 3 years, it's at 127.12. After 4 years, it's at 137.71. And after 5 years, it's at 149.18. And so you can see that each year the jump is a little bit more because each year she has more money that she's making interest on, right? So the jump from here to here is about $9. From here to here it's about 10. From here to here it's a little over, it's about 10.50. From here to here it's closer to 11, almost 12, I guess, right? And so that's going to keep happening because you have more and more money in the account every year. That's great if you've got money in an account and you're earning interest. It's bad, obviously, though, if you owe money and that interest is accumulating onto the debt. Yeah. Okay, let's talk about annual percentage yield. Okay. So one of the things with interest rates is, what's a good example to demonstrate this? Suppose you have two different investments, and one has an interest rate of 5%, the other has an interest rate of 6%. You think, oh, well, I want the 6% interest, right, because that's higher interest, so you'd make more money. But what if the 5% investment compounds, let's say, monthly, right? And the 6% compounds twice a year. So you've got more compounding but a less interest rate. So which one is the better investment? And so when we're comparing investments, there's this thing called annual percentage yield, which just basically says, hey, if it was compounded annually, other things being equal or whatever, this is how much you'd make if it was compounded annually. And so you can easily compare investments by using this is called the APY, this annual percentage yield. So you will see that on like home loans, you'll see it on investments, those kinds of things. It's just this, the percentage rate that when compounded annually would yield the same return as the given interest rate with the given compounding period. Okay, so let's apply this here. Okay, so Ursula invests $2,000 with Crab Key Credit Union at 5.15% annual interest, but it's compounded quarterly, okay? And what we want to know is basically what would be the equivalent annual percentage yield. In other words, if it was compounded once a year, what would the interest rate be in that case? Okay? So remember that annual percentage yield is just going to be this. It's compounded where it's just n is the number of years, right? So this would be 1. So basically our formula for that is just going to be P times 1 plus R, because n is just 1, right? We want to know after 1 year. And so in our example here, we would have this. A is equal to 2,000 times 1 plus R we know R when it's compounded quarterly, but remember it's going to be actually a little bit less if it's compounded once per year. So we don't know if it was to be compounded annually what the equivalent interest rate would be. Yes, we're looking for the APY, yeah. Mm-hmm. And why did I write that there? Oh, yeah, I know why. Okay, so that's the formula for annual percentage yield, right, to figure out that rate. The problem is there's two variables here, right? There's this amount, and then there's this R right here. The n is just 1. I mean, I guess we can put the 1 up there if you want, because we just want to know after 1 year. All right, so then if I take the compound interest formula, I get this equation. A equals 2,000 times 1 plus 0.0515 divided by 4 raised to the 4 times 1, or just 4. All right, so we want to know, what is the interest rate when these two things are equal? We can figure out how much this person's going to make a year with the compounding at 4 times and everything. We can figure that out, right? But then we're going to take that number and plug it in for A right here. Another way to think of that is just take these two equations. See how they're both set equal to A? Just set them equal to each other. So that's what I'm going to do. I'm going to set them equal to each other. So I get this. 2,000 1 plus r times 1 plus r is equal to, sorry, I didn't give you much space here, 2,000 times 1 plus 0.0515 divided by 4 raised to the 4. Yeah, you can graph it. You see the 2,000 on each side, though? I'm going to divide by 2,000 first because that's going to make the graphs a lot smaller. And those just drop out. So I get this. 1 plus r equals 1 plus 0.0515 over 4 raised to the 4. And then, yeah, you can just graph both sides. Or you can put this in your calculator and subtract 1 from it. I mean, as with so many of the problems in this chapter, there's more than one way that you can do it. And neither one is really better than the other. When you do this, this is what you get. You get r is equal to 0.0525. And yeah, so as a percent, I didn't give much space here, but as a percent, it would be 5.25%. Okay.
Wait, what did you do again to get that? Like, what did you call it?
To get this? To get that number? You could graph it, or if you put all of this in your calculator, you just get a number and then subtract 1 from it. So either one is fine. Because that's an ugly way to write a number, but you just plug that in your calculator. So.
But the whole time we were just trying to find the rate.
Yeah, right. What's the rate if it was compounded annually? You see it's a little bit more, right? It's 5.2% is the annual rate, which makes sense because if you compound more, you're going to make more money. So, yeah. All right, so this is really the point of that equation, is to figure out what's a better investment. Is an investment which compounds, or that makes 8.75% compounded quarterly, better or worse than an investment which makes a little less percentage but is compounded monthly? Okay, so here's your formula to compare APYs. Right? I don't know why they leave the 1 on the left-hand side here, but they do. So it looks like this: 1 plus.
Why did you write it so big? Or we don't have to.
I don't care. You can write it as big as you want. 1 plus APY is equal to 1 plus the rate over the K raised to the K. So that's your formula for APY.
This is the APY.
You got it. So we're going to find the APY for each one, and then we're going to compare them. All right, we'll figure out which one's the best investment. So investment number 1, our formula would look like this. It would be 1 plus X, or 1 plus... Do you guys want me to write X or APY? Are we going to get confused if I write X?
No. I can straight.
Okay, I'm going to write APY. So 1 plus the APY is equal to 1 plus the rate, which is 0.0875, divided by 4, because that first investment is compounded quarterly.
Wait, that's not. No, annual. Oh, quarter, sorry.
Yep. Raised to the 4. And like I said, you can see this looks a lot like the previous problem, right? So if you just take and you go in parentheses 1 plus 0.0875 divided by 4, all raised to the fourth, you get 1.090413, right? So you get this 1 plus APY is equal to 1.09041, whatever. And then when you subtract 1 from each side, you get that APY.
Wait, what's next time for?
I think it's a 1, isn't it? Yeah, it's a 1. You get that the APY is 0.09041. In other words, if you were to put this as a percentage, it would be 9.04%. Okay, questions on that one? Next, same thing. 1 plus APY, but we're going to put in the other numbers for the other investments. So the APY on the other side of that equation is 1 plus 0.087 divided by 12, all raised to the 12th power. You can plug all that into your calculator, subtract 1, you get that the APY as a decimal is equal to 0.09055. If you times that by 100 to get the percentage, then you end up with an APY that is equal to 9.06%. And so then you just can compare these two investments. One is a little bit less interest rate but compounded more frequently. One is the opposite. You can see that when we annualize them to compare their annual percentage yield, what they're going to make year over year, this is the better investment. The second one is. So APY can be a useful tool for that. Questions?